Good day, everybody. In this video, I'm going to show you how to do the subnetting questions in this class. So there's main types of subnetting questions you run into throughout this class, not including VLSM, which you'll get into later, but for now, let's focus on these four. So basically, these are the four types of questions you'll be asked to solve, either finding a subnet ID or broadcast address, finding the right subnet masks for either maximum hosts or subnets, or converting CIDR masks to dotted decimal masks. And for review, this is the CIDR mask here, is the slash and number, and this is the dotted decimal mask. It's just 4 octets. Now the main component of this lecture here is going to be teaching you how to use the magic number method. It is used to find the subnet ID and broadcast address. So this method is really good because it helps you avoid the binary math. That's all that complicated math stuff with base 2. It pretty much avoids all of it and only requires very simple math, subtraction in fact. It requires you to find patterns and determine which octets remain the same and which one, just one octet, you need to calculate. So I'll show that in a minute, but there are 6 steps, a total of 6 steps to find both the subnet ID and broadcast address. So the steps are listed here. I'll let you review them for a minute. But when you do these problems individually, like when you're given a question in your test, ask you to just find a subnet ID or a broadcast address, you only need 4 steps. And I'll go over that quickly here. So for our first example, we have this problem. Find the subnet ID of the IP address 10.77.55.3/13. So to start with our first step, we need to first examine the CIDR prefix, format the normal octets, and find the interesting octet. So for the octets of the subnet masks that are 255, we simply carry that portion of the IP address over to the subnet ID. All subnet mask octets that have 0 are also 0 in the subnet ID. The octet with a number that is not 255 or 0 is our interesting octet, which we need to complete our subnet ID. So in this example here, I have the IP address that we were given up here, 10.77.55.3. I have our subnet mask converted from the CIDR to dotted decimal notation, so 255.248.0.0. So finally, with our subnet ID, so any subnet that has 255, you simply carry that number from the IP address over to the subnet ID. So 10 is in our subnet ID. So for zeros in our subnet mask, we simply put 0 in our subnet ID. Now, in highlighted in yellow here, this is the interesting octet. It's neither 255 or 0 in the subnet mask. It's 248. So this is the subnet we need to calculate, or octet we need to calculate for our subnet ID. So step 2 is now to find the magic number. For this step, we use a special formula that employs simple subtraction to find what is known as the magic number. To find it, take the dotted decimal notation value of the subnet mask's interesting octet and subtract it from 256. So for the subnet mask, the interesting octet has 248. So we subtract 248 from 256, which gives us 8. This is what is known as the magic number. So step 3 is to find the multiple of the magic number that is closest to the interesting octet in the IP address without exceeding that value. For this example, 77 is the interesting octet, seen in this table here. Thus, we need to find a multiple of 8, which is the magic number, that is closest to 77 but does not exceed it. So I have 3 multiplication problems to explain this. So the right one here, 8 times 9 is 72. This is actually our interesting octet here. And I'll show you why it is. So 8 times 8 is 64. Multiplying our magic number by 8 gives us 64. It's too small. We need a number that is we need an interesting octet as the closest, but it cannot exceed. If there's a multiple of 8 that is closer to 77 that matches or exceeds it, or matches but does not exceed it, then this number is not right. So 8 times 10, multiplying the magic number by 10 is 80. That exceeds the interesting octet number, so it's too big. 9. So multiplying the magic number by 9 gives us 72. It's the multiple of 8 that is closest to 77 without exceeding it. So it becomes our magic number. So the final step is to place the multiple of the magic number in the interesting octet of the subnet ID. So going back to our chart, our subnet ID that was 10 dot whatever dot 0 dot 0. With our calculations in step 3 being 72, our subnet ID is now 10.72.0.0. So basically, to go over this again, so you for the start you take the subnet mask 255's you take the for 255 you take the number in the IP address, put in your subnet ID, zeros become zeros, and then you have to calculate the interesting octet, the number that is neither 255 or 0. You need to find the magic number by taking this interesting number, subtracting it from 256. Find the multiple of that magic number that comes close to the interesting octet number but does not exceed it, and then finally add it to your subnet ID. It's 4 simple steps. It takes a little bit of practice, but once you get the hang of it, it's really easy. So for a second example, we need to find the broadcast address of this same IP address. So basically, the first step is very similar to the first step is very similar to the last one, or our last example. So 255's, we carry the number from the IP address to the broadcast address. However, zeros now become 255's in our broadcast address. Anything that any sub or any octet that has 0, ignore those numbers, just put 255. Magic number rule remains the same. It's highlighted here. So this is the number in the broadcast address, as you see right here, that we need to change. So step 2, once again, is to find the magic number. Same as before. Take the interesting octet number from the subnet mask, subtract it from 256, and that gives us our magic number. So step 3 is to find the multiple of the magic number that is closest to the interesting octet in the IP address without exceeding that value. So basically, it's the exact same step from last time. So find the number that comes closest, or find the number that you can multiply by the magic number that comes closest to the interesting octet number without exceeding it. So the additional step we have here is to find the broadcast address by adding the magic number to the subnet ID's interesting octet value, then subtracting 1. So we have to add, mistake here. Okay, yeah, sorry about that. So adding the magic number to the subnet ID's interesting octet value here gives us 80. Oops, that's another mistake. Well, actually that is right, but you'd also need to subtract 1. So 72 is the number we have here for our subnet ID. We add the magic number, which is 8, then you simply subtract 1, that's 79. So with this number 79, it gives us the broadcast address of 10.79, that's the number we added, .255.255. That's our broadcast address. So basically, you follow for finding the broadcast address. You follow the majority of the steps from the subnet ID example, but you have to take the number you multiply, add the magic number once, and then subtract that number by 1, and that gives you your interesting octet for your broadcast address. So I have a magic number conversion chart. What I recommend is you memorize the dotted decimal notations that correspond to the CIDR masks you see, and then memorize the magic number that also correspond to them. So, for example, if you're given a IP address for /18, you should recognize that your magic number is 64. So you can go. So what I recommend is when you see 9, 10. So think in your head 9, 10, 11, 12, 13, 14, 15, 16, and so that's the first. So what I'm trying to say here is for the classless subnets you see here, the classless masks, you want to memorize them by first, second, third, fourth, fifth, sixth, seventh, eighth. So you can kind of forget these because classful addresses are really easy to figure out. But when you see, so what I'm trying to say here is that After the first classful address, you want to keep these numbers in order. So when you see a 9, 10, 11, 12, you want to memorize 128, 64, 32, 16. So so that will help you quickly figure out which magic number you need based on the subnet CIDR mask you receive. So our other problem is finding the CIDR mask for maximum subnet/host. So there will be problems in this course where you will be provided an IP address and the needed subnets and hosts for a network. With this information, you will be expected to find the subnets that would provide the network the maximum number of hosts, or subnets or hosts. In other words, you need to find the one subnet mask in CIDR notation that will provide the maximum number of subnets while still supporting the required or minimum number of hosts, and vice versa. The following steps will demonstrate a shortcut for solving these problems. So there are just simply 3 steps. So first we examine the values we were given. We calculate the net required subnet host bits for each value, and then calculate the 2 subnet masks, or 1 for our problem, that respectively provide the maximum number of subnets and maximum number of hosts. So here's another problem. Find the masks that each give the maximum subnet and host bits for the following requirements. You're given So for your problems, you typically be given an address, the needed subnets, and needed hosts, and just be asked to find one of these, but I'll be demonstrating them both here. So step 1 is to basically just examine the values we were given. For problems like this, you will be asked to find a mask that would provide the maximum that would maximize the number of subnets or maximize the number of hosts. If you need to maximize subnets, you need to find the required number of host bits using the number of needed hosts in the example. So if your problem asks you to maximize subnets, you need to focus on the hosts, the required hosts. Conversely, if you need to maximize hosts, you need to focus on the number of subnets that are needed. So just in your head, when you see these problems, if the question asks for subnets, you need to focus on the host number here. If you're asked to maximize subnets, you need to find host. If you're asked to maximize host, you need to deal with this number, the subnet number. So step 2 is to calculate the required subnet host bit or /host bits for each value. So for maximizing subnet bits, we need to find the needed host bits. The formula we can use for this is hosts equals 2 to h power minus 2, where h equals host bits. That's the number we need to find. With this formula, find the closest number that matches or exceeds the number of needed hosts. For this example, we need 6 hosts. So 6 is less than or greater than 2 to the h power. Forgive me for this. 2 to the h power minus 2. So the number that will match this is 2 to the third power equals 8 minus 2 equals 6. So you need to remember when you're dealing with hosts, you need to do minus 2. That accounts for the subnet ID and broadcast address. So we need 6 hosts. 2 to the third power equals 8. So we subtract it by 2, we get 6. And the number we are concerned with is 3. 3 is the number of required host bits. So our answer for this question is 3. So for maximizing host bits, we need to find the needed subnet bits. The formula we can use for this is subnets equals 2 to the s power, where s equals subnet bits. With this formula, we find the closest number that matches or exceeds the number of needed subnets. So what I mean by closest for these examples, you want to find something that matches the answer, but doesn't go one or more above. You need to find the closest one, otherwise your answer will be incorrect. So for this example, we need 15 subnets. So 16 equals 2 to the fourth power, which is, as you can see, it's not exactly 15, but it's the closest. If we did 2 to the fifth power, let me think what that would be. 16, 32. That would be 32. So that would not be right. We'd be overestimating the number of subnet bits, or required subnet bits. So our answer again is S, which is 4 in this case. It's the required number of subnet bits. So it's the power number in both cases that is your answer. Or not your answer, but the number we need to find your answer. So finally, step 3, calculate the 2 subnet masks in CIT or CIDR notation that respectively provide the maximum number of subnet and maximized number of hosts. So again, these answers need to be written in CIDR notation when you put them in your answers for this class. So to find the subnet mask that provides the maximum subnets, use this formula, 32 minus h, where h equals the required host bits. So going back to our problem, we found that the required host bits for this example is 3. So we simply subtract 3 from 32, and we get /29. This maximizes the number of subnet bits while meeting the required host bits, bits to meet the required number of hosts. So to find the subnet mask that provides the maximum hosts, use this formula, n plus 8s, n plus s, where n equals network bits and s equals required subnet bits. To find the network bits, examine the IP address you're given and determine which class it resides in. Because 192.168.44.0 resides in class C, the number of network bits is 24. So as a little review, when you work with class A addresses, the 8 will be your answer for network bits, class B is 16, and class C is 24. So once you find the required network bits, simply add them to the required subnet bits. So 24 from 192.168.44.0 plus 4, which is the subnet bits we found here, we get 28, and this maximizes hosts. So that's how you solve these kinds of problems. And I've also attached a little table here, a chart for powers of 2. So I would recommend memorizing this. This really helps for your calculations when you're doing these formulas. It really helps to memorize the powers of 2. Just the first 10. I don't think you need to ever go above 10 in this class. I could be wrong. I want to memorize like 2 to the 11th power just in case, which is basically 2048. And for when you're working with the host bits, remember to subtract by 2. This table, by the way, is from this website, Power of 2 table. My Math Tables is the website. I left a link here. I might post this PowerPoint if anybody's interested. Now there was one other thing that you need to do is from CIDR to mask notation. So CIDR to DDR VN subnet mask. So you can basically for that, I would recommend just looking up some kind of website. You can see right here, Wikipedia or some other website might have something simpler, but yeah, just memorize your CIDR to dot decimal notation. It's pretty simple. Basically, for every 8 numbers in a class, so you have 128, 192, 224, 240, 248, 252, 254, 255. I highly I highly recommend memorizing those numbers: 128, 192, 224, 240, 248, 252, 254, 255. So when you count up from the classful mask, so starting from 8, so after 8 you have 9 to 16. You go 128, 192, 224, and so on. I recommend memorizing those numbers to help you with those kind of questions where you have to convert CIDR notation to decimal notation. So that concludes this video. If you have any questions concerning subnetting, you can meet me in my office hours or just email me. I'll be happy to help you out. Thank you for watching this video and have a good day.